Hi and Assalamualaikum sir. We are from 2DEK section 1 will present about our mini project of DEKE 2123 Power Electronics subject. Our mini project is about analysis of DC-DC boost converter circuit. The group members, for first one, me, Nur Syafiqah binti Maknawi. The second one, Nur Syamimi binti Muhammad Zamari. And the last one, Siti Nur Syahmi binti Muhammad Azhar. For pre-project circuit operation, first one, step-up converter for the output voltage is larger than input. For first loop, the voltage input source is connected with inductor while across the source the switch connect. And for second loop, a diode is connected to a capacitor and resistor which are connected in parallel. And then for switch close, value of voltage input same as voltage inductor. Diode does not become forward bias, current will flow more dominant, flowing to the switch. And then for switch open, current will flow into diode and capacitor. The inductor current is continuous. It's about always positive. And the average power supply by the source is equal to average power absorbed by the load resistor. Next, the ripple can be reduced by increasing switching frequency and increasing capacitor size. For the duty cycle, waveform will look like square wave. And the last one, for output voltage and output current, waveform will look like triangle wave.
In this slide, we have three waveforms. They are duty cycle pulse, output voltage, and output current. As we can see here, the duty cycle have a square wave, while the output voltage and output current have the triangle wave.
Next, for derive the equations for output voltage, we can derive like this. And first one, the inductor voltage is equal input voltage minus output voltage, and can derive like this. And for the chain of current inductor close plus the chain of current inductor open is equal to 0. And the last one, we can get the output voltage is equal to input voltage divided of 1 minus duty cycle. And then for output voltage ripple, definition of capacitance, charge equal to capacitance multiply of output voltage. For the chain of charge equal to capacitance multiply of chain of output voltage. And for to find the chain of output voltage is equal to chain of charge divided of capacitance. The chain in charge is the area of the rectangular below the time axis. For the chain of charge is equal to the output voltage divided of resistance multiply of duty cycle multiply with period. Thus, for the output voltage ripple equal to output voltage multiply of duty cycle and multiply of the period divide of resistance multiply of capacitance, and equal to output voltage multiply of duty cycle divide of resistance multiply with capacitance and frequency.
For the simulation characteristic, we have the task problem. So this is the task problems.
We represent my part of this simulation part. Okay, for the simulation, we are using the Simulink or MATLAB simulation software to construct the circuit of the DC-DC boost converter. For this circuit, we apply the DC voltage source where the value is 50 volt, and then we apply we connect to the inductor. The value is 400 microhenry, and then we apply to the diode, and then apply to the ideal switch, also the pulse generator, and we apply to the capacitor and then we apply to the capacitor. The value is 100 microfarad, and also the resistor, where the resistor or the load, where the value is 50 ohm. The resistor is connect in parallel with the capacitor. We also use other props to get the value, to get the waveform, and also to measure the current and voltage. The pulse generator setting, we choose one value of the frequency and one value of the duty cycle. So for the frequency, we choose 25 kilohertz, and then for the duty cycle, we choose 0.7. That value is for the converter switch or the ideal switch that from the circuit. So how to get the waveform of the duty cycle signal? We use the scope block. We'll connect with the pulse generator. So after we substitute the value of the period pulse width in the block parameter pulse generator, then we run the simulation. The simulation time is 2 seconds. Okay, and then so form of the duty cycle signal will looks like square wave. Waveform. Next, we go to measure the voltage, the output voltage. So to get the value and the waveform of the output voltage, we connect the voltage measurement blocks in parallel with the load or the resistor. So from there, we also connect with the scope and the display. The display will show the value of the output voltage, and then the scope block will show the waveform. So the waveform we got from this output voltage looks like triangle waveforms. And last, we measure the current inductor. To get the current inductor, we connect the current measurement block with the in series with inductor. So we also connect with the display and the scope block. The display will show the value of the current inductor, and the scope block will show the waveform. As shown in the scope block, the waveform of the current measurement of the inductor current looks like triangle waveform. And now we go to the comparison between simulation and calculation of the output voltage and the inductor current. So for the simulation that we for the output voltage, value of the simulation part is 166.6 volt, and then for the calculation we got 166.67. So for the current inductor, for the simulation we got 9.5557 ampere, and then for the calculation we got 11.111 ampere. Now we go to the calculation part, where this calculation part is to how we get the value of the voltage output and output voltage and the inductor current. So for the voltage output, we use the formula is V input divided by 1 minus D or duty cycle. So just substitute the value, and then we will get the value of the output is 166.67 volt. And then for the inductor current, we get from the formula of V input divided by 1 minus D, the power of 2, and multiply with the R resistor. So just substitute the value, and then we will get the value is 11.11 ampere. And then we also calculate the I maximum and I minimum. This for I maximum and I minimum, the formula are same. We just change the minus and plus. So for I maximum, we use the formula of I inductor current plus V input multiply with dt divided by 2 inductor. But for the I minimum, we still same, just change the plus to the minus. So for I maximum, we get the value is 12.861 ampere, and then for the I minimum we get is 9.361 ampere.
My name is Siti Nurshami, and I will explain about the discussion of the result. Based on the inductor current waveform observation, the overshoot occurs at the beginning of the waveform and approaches 90 ampere. When the duty cycle decreases to 0, the settling down occurs and the waveform gets into a steady state in a triangle waveform. The inductor current is 11.111 ampere based on the calculation. Based on the output voltage waveform observation, the waveform shape was similar to the inductor current waveform. The overshoot occurs at 300 voltage and gets into the steady state after settling down. The output voltage is 166.67 voltage. Both of the waveforms' time to complete one cycle was 0.4 microsecond. The maximum and minimum of the inductor current are 12.816 ampere and 9.361 ampere. In conclusion, we could explain the significances of using the gate driver for converter circuits and understand the principal operation of the boost DC-DC converter circuit. We also could analyze the boost DC-DC converter performance under variations of the parameters. The simulation was done in MATLAB software, also brought out more understanding of the circuit's waveforms, but we have to verify that the value from the simulation was similar to the calculation value. In the calculation section, we can see that both results are the same. Besides, the calculation got more accurate because the simulation value was simplified.